Good day, everyone. We will discuss the higher order derivatives of functions and the chain rule. So let us discuss first the higher order derivatives. Let's consider the polynomial f of x equal to x to the fourth plus 3x cubed minus 4x plus 2. The derivative of the function denoted by f prime of x is equal to derivative of x to the fourth is 4x cubed. Derivative of 3x cubed is 9x squared. And derivative of negative 4x is negative 4, while the derivative of positive 2, which is a constant, is 0. So as you can see, the derivative of the function is again differentiable. Therefore, we may still differentiate f prime of x to get the derivative f prime of x, which is or denoted by f double prime of x. And the derivative of 4x cubed is 12x squared, and the derivative of 9x squared is positive 18x, and the derivative of negative 4, which is a constant, is 0. So as you notice, this is again another differentiable function. So we call f double prime and its subsequent derivatives the higher order derivatives of the function f. So like f prime here, which we interpret as the slope of the tangent line, the function f double prime of x will have an interpretation on the graph of f, and this will be your lesson in college if you will take calculus subjects. It also has an important interpretation in physics. If f denotes the displacement of a particle. But for now, this lesson will reinforce our skills in differentiating functions. So, let us consider again the function y equal to f of x. So the derivative, which is denoted by y prime, or you can have f prime of x, or you can have this notation, the derivative of y with respect to x, or this is called the first derivative of the function f with respect to x. So the derivative of the first derivative, so if you will have the derivative of the derivative, then it will be called the second derivative of f with respect to x, and is denoted by any of the following symbols. You can have y double prime, f double prime, or we can have this, meaning it is the second derivative of y with respect to x, or we can have this notation, and the derivative of the second derivative becomes the third derivative of f with respect to x and is denoted by any of the following symbols. So you'll just add another prime, or you can have this, or this one. So in general, the nth derivative of f with respect to x is the derivative of so the nth derivative will be the derivative of the previous derivative and is denoted by any of the following symbols. So this differentiates from the exponent. So this is not the exponent. This is not an exponent. This is the notation for the derivative of the function f with respect to x. Nth derivative, or we can have this. So formally, we have the following definition. The nth derivative of the function f is defined by f prime of x is equal to this expression for n equal to 1, and meaning that is the first derivative, and the nth derivative is given by this expression. That is, for n is greater than 1. So we will just replace this with, for example, we have n equal to 2. So that is the second derivative. So all n will be replaced by 2. So if n is equal to 3, then that is the third derivative of the function with respect to x. So we will just replace n with 3 here, and so on. Provided that these limits exist. Thus, the nth derivative of f is just the derivative of the n minus 1, or the previous derivative of f. We have the following remarks. The function f can be written as f of x, meaning n here is equal to 0. So that is the function, or the given function. Second, in the notation, the nth derivative, n is called the order of the derivative. So we have the higher order derivatives of functions. So n here is called the order of the derivative. That is the second order, the third order derivative, the fourth order derivative, and so on. So for example, find the fourth derivative of the function. So if you're given the function x to the power of 5 minus 3x to the power of 4 plus 2x to the power of 3 minus x squared plus 4x minus 10, we will start finding the first derivative before we can proceed to the fourth derivative. So we will start with the first derivative always. Second, third, fourth, and so on. If it depends to what derivative is asked. So the first derivative, so the derivative of this function is 5x to the power of 4 minus 3 times 4, that is 12x to the power of 3 plus the derivative of 2x cubed, that is 2 times 3, 6, x, 3 minus 1, 2. Minus the derivative of x squared is 2x plus the derivative of 4x is 4 and the derivative of a constant is 0. So we have the first derivative of the function f with respect to x. Now let's go to the second derivative of x, or the second derivative of f with respect to x. So in this, our function is the first derivative. So we will get the derivative of the derivative. So 5 times 4, 20, x, 4 minus 1, 3, minus 12 times 3, 36, x, minus 1 sa exponent, then we have 2, plus 6 times 2, 12, x, minus 1, so we have exponent 1, minus the derivative of 2x is 2, and the derivative of a constant is 0. So we have the first derivative, the second derivative of f with respect to x. Now, let's move on to the third derivative of the function f with respect to x. So this time, we will differentiate the second derivative. So we have 20 times 3, that is 60, x minus 1 sa exponent. So we have 2 minus 36 times 2, that is 72, x minus 1 in the exponent. So we have exponent 1 left, plus derivative of 12x is 12, and the derivative of a constant is 0. So since we are looking for the fourth derivative of the function, so the fourth derivative of the function with respect to x is equal to, now this time, let us differentiate the third derivative. So 60 times 2, that is 120, x minus 72x, derivative of that is 72. And the derivative of a constant 12 is 0. So we have the fourth derivative. This is the final answer. So if you're asked to find the fifth derivative, then we will just differentiate the fourth derivative. For the sixth derivative, then we will differentiate the fifth derivative, and so on. So another example, find the first and the second derivatives of the function defined by the equation. So we will recall our product rule. So what is product rule? If we are given h of x equal to f of x times g of x, then by product rule, the derivative of h with respect to x is given by, you just copy the first f of x times the derivative of the second plus, we copy the second function times the derivative of the first, right? So using the product rule, we will first compute the first derivative of the function. So first derivative, y we have y prime. And that is equal to, since this is, let us denote this as our first function and our second function. So we just copy f of x, or the first function, that is 3x squared minus 4, right? Then we'll multiply this with the derivative of x squared minus 3x, plus we copy the second function, that is x squared minus 3x, times the derivative of the first function, which is 3x squared minus 4. So you just copy this one. You have 3x squared minus 4 times the derivative of x squared, that is 2x, derivative of negative 3x, that is negative 3. Do you follow? Plus, copy x squared minus 3x times the derivative of 3x squared minus 4. So the derivative of 3x squared is 6x, and the derivative of negative 4, which is a constant, that is 0. Then we simplify the expression. So since we are to find the second derivative, then it is easier if we simplify these terms. So 3x squared times 2x, you just multiply that using FOIL method. If you know how to, then we distribute this, the second term. So 3x squared times 2x, that is 6x cubed. 3x squared times negative 3, that is negative 9x squared. Negative 4 times 2x, that is negative 8x. Negative 4 times negative 3, that is positive 12. So we're done with this. And how about this one? So we will just distribute 6x. So x squared times 6x, that is positive 6x cubed. Then 6x times negative 3x, that is negative 18x squared. Then we combine like terms. So 6x cubed plus another 6x cubed will give us 12x cubed. Negative 9x squared minus 18x squared, that will give us negative 27x squared. Negative 8x, there's no other term with variable x only, so you just copy negative 8x. Also, the constant 12. So that is the first derivative of the function. How about the second derivative of the function? So similarly, we will just get the derivative of this function. So notation for the second derivative, that is y double prime. So we'll just get the derivative of this function, 12x cubed minus 27x squared minus 8x plus 12, to get the second derivative. So the derivative of 12x cubed is 36x, right? 12 times 3, that is 36. You copy x, then the exponent minus 1, so we have squared. Next, negative 27 times 2, that will give us negative 54. Copy x, then 2 or exponent 2 minus 1 will give us an exponent 1. right? So derivative of negative 8x is negative 8. And the derivative of a constant is 0. So we have our second derivative. We have our first derivative, our second derivative. So we answered the problem. Another example, let y be equal to 3x plus 5 all over x squared plus 4. Find the second derivative of y with respect to x. So, since we are to find the second derivative, we will first find the first derivative of y with respect to x. Okay, as you notice, this is a rational function. So we will make use of the quotient rule. So if you're given h of x equal to f of x over g of x, where g of x here should not be equal to 0, so the derivative of h with respect to x is equal to, using quotient rule, we copy the denominator, g of x, right? Then we multiply by the derivative of the numerator, that is f prime of x, minus, we copy the numerator, f of x, times the derivative of the denominator, that is g prime of x. And then, the denominator will be g of x squared. So if this is f of x, and the denominator is g of x, so the derivative of y using quotient rule is equal to, first we copy x squared plus 4. Then the derivative of 3x plus 5 minus, we copy the numerator 3x plus 5 times the derivative of the denominator x squared plus 4 over the denominator x squared plus 4 squared. Then this is equal to, we copy x squared plus 4 times the derivative of 3x plus 5. Derivative of 3x is 3. And the derivative of 5 is 0 since it is a constant. Minus, you copy 3x plus 5 times the derivative of x squared plus 4. So derivative of x squared, that is 2x. And derivative of 4, which is a constant, is equal to 0. Divided by x squared plus 4 quantity squared. Then we simplify this. So you just distribute 3, also 2x. So 3 times x squared, we have 3x squared plus 3 times 4, that is 12, minus 2x times 3x, that is 6x squared. 2x times 5, that is 10x, but we have a negative here, so we multiply by negative, 10, that is negative, 10x. So, as with negative 6x squared here. So, we distribute also the negative sign. Don't forget about that. Divided by x squared plus 4 quantity squared. So, from this, since we have like terms, so we will combine the terms in the numerator. So we have 3x squared minus 6x squared. That is negative 3x squared. We copy negative 10x. And then positive 12. Divided by x squared plus 4 quantity squared. So this is positive 12. Sorry. Again, this is negative 10x and then positive 12. Okay, so we have the first derivative of y. So let's proceed in finding the second derivative of y with respect to x. So since we have the denominator x squared plus 4 quantity squared, we can expand that one. So that is equal to negative 3x squared minus 10x plus 12 divided by, we expand this, so x squared squared, that is x to the power of 4. X squared times 4, that is 4x squared times 2, that will give us positive 8x squared. And that third term, 4 squared, we have positive 16. So we expand this for us to easy find the second derivative. Since this is our f of x now and our g of x. So since this is also a rational function, so we will make use again of the quotient rule. So the derivative of y with respect to x, that is the second derivative now, and the derivative of this function is equal to, so again, using the quotient rule, we copy g of x, so that is x to the power of 4 plus 8x squared plus 16. And then we multiply by the derivative of the numerator. So we can directly write the derivative, or we can have this notation for easy understanding. So we can have that one, or we can easily or directly write the derivative here. So it's up to you. So the derivative of negative 3x squared, so we will just write it here para pwede ra ninyo balik-balikon ang video in case you forgot. So the derivative of negative 3x squared minus 10x plus 12 minus, you copy the numerator, that is negative 3x squared minus 10x plus 12 times the derivative of the denominator, that is x to the power of 4 plus 8x squared plus 16. So you are about to get the derivative. Not yet the derivative, sorry for that. So divided by x to the power of 4 plus 8x squared plus 16 quantity squared. So we'll just remember or recall the rules of differentiation. So this is equal to, we copy x to the power of 4 plus 8x squared plus 16 times, this time we get the derivative of the numerator. Derivative of negative 3x squared is negative 6x. Derivative of negative 10x, that is negative 10. And derivative of a constant 12 is 0. Minus, you copy. So don't forget the close or the open and close parenthesis. So copy negative 3x squared minus 10x plus 12. We multiply by the derivative of the denominator. So derivative of x to the power of 4 is 4x cubed. Derivative of 8x squared is 16x. Derivative of 16, that is a constant, so that is 0. So this is all over x to the power of 4 plus 8x squared plus 16 squared. So for now, since we are up to the second derivative only, then we will just let this as is. We will not expand this anymore. So the numerator, we will simplify that. So again, we make use of the distribution method. So we have x to the power of 4 times negative 6x, that is negative 6x to the power of 5. X to the power of 4 times negative 10, that is negative 10x to the power of 4. 8x squared times negative 6x, that is negative 48x cubed. 8x squared times negative 10, that is negative 80x squared. 16 times negative 60, so 16 times negative 6x, that is negative 96x. 16 times negative 10, that is negative 160. So for this product, we have 4x cubed times negative 3x squared, that is negative 12x to the power of 5 times negative, since we will distribute the negative sign to the product, so that is positive 12x to the power of 5. Next, negative 3x squared times 16x will give us 48x cubed. That is a negative, right? So we have a times negative, so we have positive 48x. This is second exponent 2 and exponent 1, so that is 48x cubed. Next, negative 10x times 4x cubed, that will give us negative 40x to the power of 4, right? 3 plus 1. So we have 4 times negative. So we have positive 40x to the power of 4. And then negative 10x times 16x. That will give us negative 160x squared times negative. So that is positive 160x squared. Next, we have 12 times 4x cubed. That will give us 48x cubed. Positive times negative. So we have negative 48x cubed. Right? And last, 12 times 16x will give us 192 times negative. So we have negative 192x here. Sorry, no space. Divided by, we just copy this one. So that is x to the power of 4 plus 8x squared plus 16 quantity squared. So from this, we will combine all like terms in the numerator. So we'll start with negative 6x to the power of 5 plus 12x to the power of 5. That will give us 6x to the power of 5. So negative 10x to the power of 4 plus 40x to the power of 4. That will give us positive 30x to the power of 4. And we have negative 48x cubed plus 48x cubed. That will give us 0 minus 48x cubed. So we have negative 48x cubed. So we have negative 80x squared plus 160x squared. That will give us positive 80x squared. And negative 96x minus 192x. That will give us negative 288x. And then we have negative 160. And then we'll just copy the denominator, the quantity x to the fourth plus 8x squared plus 16 squared. So we're done. This will be our final answer. So pwede na nga dili nato ni expand ang atuang denominator. So another example, we are to find the third derivative of the function defined by negative 4x squared times e to the power of x plus 5x times e to the power of x minus 10 e to the power of x. So since our first term, negative 4x squared times e to the power of x, this is a product of two expressions or functions, plus the second term is also a product of two functions, 5x and e to the power of x. So we will use the product rule. So what is product rule again? If you're given h of x equal to f of x times g of x, then the derivative of the function h with respect to x is equal to, we just copy the first function f of x, then we multiply by the derivative of the second function, So that is g prime of x plus, we copy g of x and then multiplied by f prime of x, or the derivative of f with respect to x. So the derivative of g here, the first derivative, we will first get the derivative of the first term. So if this is our f of x and this is our g of x, or the first function times the second function, then using the product rule, we will copy first negative 4x squared, and then we multiply by the derivative of e to the power of x, which is e to the power of x, plus we copy e to the power of x times the derivative of negative 4x squared, and that is negative 8x. And then we will get the derivative of the second term, 5x times e to the power of x. So this is our first function now and our second function. So we have plus, because of the positive sign. So plus, we copy 5x times the derivative of e to the power of x, that is e to the power of x, plus we copy e to the power of x times the derivative of 5x, which is 5. And then the derivative of negative 10 e to the power of x is negative 10 e to the power of x. Okay, so we will simplify this expression. This will give us negative 4x squared e to the power of x minus 8x e to the power of x plus 5x e to the power of x plus 5 e to the power of x minus 10 e to the power of x. So we combine like terms. We have negative 4x squared e to the power of x, negative 8x e to the power of x plus 5x e to the power of x. That will give us negative 3x e to the power of x. And 5e to the power of x minus 10e to the power of x. That is negative 5e to the power of x. Okay, so if we will get the derivative of the function, some of us will find a way, or an easiest way, to find the derivative of the function. So for now, we can find the derivative of this function to get our second derivative, or we can rewrite this in this form. Since e to the power of x is common, then we factor out e to the power of x. We are left with negative 4x squared, negative 3x minus 5. Okay, so if we are to use this form, we are to make use of the product rule again twice for the first term and the second term. While if this form will be used, then we are only using the product rule once. So either of the two will give us the same result. So for our second derivative of the function g with respect to x, we'll make use of this form. So since this is a product of two functions, e to the power of x and negative 4x squared minus 3x minus 5, we'll make use of product rule again. So this is our first function and the second function. So first, we'll copy e to the power of x, and then we multiply by the derivative of negative 4x squared minus 3x minus 5, which is negative 8x minus 3, plus we copy the second function, that is negative 4x squared minus 3x minus 5. And then, multiplied by the derivative of e to the power of x, which is e to the power of x. And since e to the power of x is common in both terms, we factor out e to the power of x, and then we are left with negative 8x minus 3 plus, this is, since this is positive times negative, this is negative 4x squared, negative 3x minus 5. So we combine like terms, we have e to the power of x times negative 4x squared, negative 8x minus 3x, that will give us negative 11x, and then negative 3 minus 5, that is negative 8. So we have our second derivative of the function g with respect to x. So either we'll use this notation for the first derivative, or we can have this g, which is n here, or the order is 1. Same with the second derivative, we can also use this notation for the second order derivative. And then our third derivative of the function, we have g triple prime of x, or we can use this notation. So either of them will do. Okay, so again, we'll make use of the product rule since it is a product of e to the power of x and negative 4x squared minus 11x minus 8. So we'll copy first e to the power of x, and then we multiply by the derivative, that is negative 8x minus 11, plus we copy negative 4x squared minus 11x minus 8 times the derivative of e to the power of x, which is e to the power of x. So again, common factor e to the power of x. Then we are left with negative 8x minus 11 minus 4x squared minus 11x minus 8. And then if we simplify this, it will give us e to the power of x times negative 4x squared, negative 8x minus 11x, that is negative 19x, negative 11 minus 8, that will give us negative 19. So we are done. This is our third derivative of the function g with respect to x. So another example, if f of x is equal to e to the power of x times sine x minus 3e to the power of x times cosine x, find the fifth derivative of the function f with respect to x. So we differentiate repeatedly here by applying the product rule and obtain our first derivative, that is, so again, same with the previous example, the first term is a product of e to the power of x and sine x. So we'll make use of the product rule here. We copy e to the power of x first times the derivative of sine x, which is cosine x, plus we copy sine x times the derivative of e to the power of x, which is e to the power of x. Minus, so again, this is a product of 3e to the power of x and cosine x. So, by product rule, we copy 3e to the power of x times the derivative of cosine x, that is negative sine x. It is important to use grouping symbols to differentiate the terms. Because, for example, if we are to directly write negative sine x, maybe some of you will misinterpret it as 3e to the power of x minus sine x, which is different from the correct way of writing it as 3e to the power of x times negative sine x. So, it is easier for us to make use of a grouping symbol. So, plus, we copy cosine x, and then we multiply by the derivative of 3e to the power of x, which is 3e to the power of x. So, we have negative, e to the power of x times cosine x plus e to the power of x sine x. And then we have a negative sign here. We distribute that. So that is negative times negative. We have positive 3e to the power of x sine x. And then negative times positive, we have negative 3e to the power of x cosine x. Okay, so we combine like terms. We have 1e to the power of x cosine x plus or minus 3e to the power of x cosine x. That will give us e to the power of x. No, that is negative, sorry. Negative 2 e to the power of x cosine x, and then e to the power of x sine x plus 3e to the power of x sine x, that will give us positive 4 e to the power of x sine x. So from here, common monomial factor e to the power of x, so we factor out e to the power of x, that will give us 4 sine x minus 2 cosine x. So either of the two will do, but this is the easiest form that we can use to find the second derivative of the function f with respect to x. Okay, so by product rule again, we copy e to the power of x, and then we multiply by the derivative of 4 sine x, which is 4 cosine x, minus 2, derivative of cosine x is negative sine x, plus, we copy 4 sine x minus 2 cosine x times the derivative of e to the power of x, which is e to the power of x. So, factor out again e to the power of x, sorry. And then we are left with 4 cosine x, negative 2 times negative sine x, that will give us positive 2 sine x, plus 4 sine x, minus 2 cosine x. Okay, so e to the power of x times, we have 4 cosine x minus 2 cosine x, that will give us 2 cosine x, and 2 sine x plus 4 sine x, that is positive 6 sine x. We have the second derivative of the function f with respect to x. How about the third derivative of the function f with respect to x? So by product rule again, we copy e to the power of x times the derivative of 2 cosine x, that is 2 times negative sine x, plus the derivative of 6 sine x, which is 6 cosine, plus 6 cosine x, plus we copy 2 cosine x plus 6 sine x times the derivative of e to the power of x, which is e to the power of x. Then factor out e to the power of x again, and then we are left with negative 2 sine x plus 6 cosine x plus 2 cosine x plus 6 sine x. So we have e to the power of x times 6 cosine x plus 2 cosine x, that is 8 cosine x, and then 6 sine x minus 2 sine x, that will give us positive 4 sine x. So we have the third derivative of the function with respect to x. So for the fourth derivative of the function f with respect to x, from the third derivative, we copy e to the power of x times the derivative of 8 cosine x, that is 8 times negative sine x, plus the derivative of 4 sine x, that is 4 cosine x, plus we copy 8 cosine x plus 4 sine x times the derivative of e to the power of x, that is e to the power of x, equal to, factor out e to the power of x, then we are left with negative 8 sine x plus 4 cosine x plus 8 cosine x plus 4 sine x. Then we combine like terms. We have e to the power of x times We have 8 cosine x plus 4 cosine x. That will give us 12 cosine x. And then negative 8 sine x plus 4 sine x. That will give us negative 4 sine x. So how about the fifth derivative of the function f with respect to x? So by product rule again, we copy e to the power of x times the derivative of 12 cosine x minus 4 sine x, that is 12 times negative sine x. Sorry, nani siya parenthesis diri ha. Kay si 8 times negative sine x lang na siya. Wala ning dili ni diri. Okay, sorry for that. So derivative of negative 4 sine x is negative 4 cosine x plus we copy 12 cosine x minus 4 sine x times the derivative of e to the power of x, that is e to the power of x, equal to, factor out e to the power of x, and then we are left with negative 12 sine x minus 4 cosine x plus 12 cosine x minus 4 sine x. And then, we simplify that, e to the power of x times, we have 12 cosine x minus 4 cosine x, that will give us 8 cosine x, and then negative 12 sine x minus 4 sine x, that will give us negative 16 sine x. So, we're done. We have the fifth derivative of the function f with respect to x with a given function. So that was the higher order derivative. So let us now move on to chain rule. If you answered your practice exercises, you observed some functions there. Let's say h of x equal to the quantity 3x plus 4 squared, and we have told you that you can rewrite that as a product of 3x plus 4 and another 3x plus 4. Then you make use of the product rule, or you expand this and then get the derivative of the function. But using chain rule, we can make use of the formula here, that is to make it easier. So for chain rule, in this lesson, you will learn a rule that will allow you to differentiate a given function without having to perform any preliminary multiplication or apply any special formula. The chain rule below provides for a formula for the derivative of a composition of functions. So what is chain rule? Let f be a function differentiable at c, and let g be a function differentiable at f of c. Then the composition g of f is differentiable at c, and we are given with this formula, meaning we'll get the derivative of g at the evaluation of the function times the derivative of f. So another way to state the chain rule is the following. If y is differentiable function of u defined by y equal to f of u, and u is differentiable function of x defined by u equal to g of x, then y is a differentiable function of x, and the derivative of y with respect to x is given by this formula. So, in words, the derivative of a composition of functions is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So, when can you say that we are to make use of chain rule or the ordinary rules of differentiation only? So, according to what I said earlier, that the derivative of a composition of functions or making use of chain rule is the derivative of the outer function. So from here, let's consider this example. The outer function here is the function with the exponent 2, and the inner function will be 3x plus 4. So if we have function f of x equal to x squared, it is still the same that the outer function here is with the exponent 2 and the inner function will be x. So since we are used to get the derivative of x squared, right, using power rule, the derivative of this function is 2x. But if we are to make use of chain rule, then the derivative of x, i-multiply pa na nato siya, and that is equal to 1. Still, we are given 2x, or the derivative of the function is still 2x. So with this, h of x, the derivative of h with respect to x, using power rule, so the derivative of the outer function here is we copy the exponent 2 and then evaluated at the inner function, which is we are only copying the inner function, which is 3x plus 4, and then 2 minus 1 because of the power rule, right? And then we multiply this expression by the derivative of the inner function. So we are not yet done with this only. We are still to multiply by the derivative of the inner function, which is 3, right? Because derivative of 3x is 3 and derivative of 4 is 0 since it is a constant. So same with this concept. So if you simplify this one, we have 2 times 3, that is 6 times 3x plus 4, and we are only left with exponent 1. So we can still simplify this. We distribute 6, then we have 18x plus 6 times 4, that is 24. So we have our derivative of the function using chain rule. So if the derivative of the inner function is just 1, then we are safe that we found the derivative of the function. But if the derivative of the inner function is not equal to 1, then we are still looking for, or we are not yet done in finding the derivative of the function. We are not yet complete in finding the derivative of the function. So that is by chain rule. Okay, so we have the following example. If f of x is equal to 3x squared minus 2x plus 4, quantity squared, find the derivative of the function. If we make use of this formula, the derivative of y with respect to x, that is, we are finding the derivative of y with respect to u times the derivative of u with respect to x. So, from here, the function, we can let that, or we can rewrite that as y equal to 3x squared minus 2x plus 4 quantity squared. So from the another way or the remark, y here is equal to f of u. So we can write this as, or we let u be equal to 3x squared minus 2x plus 4. So we have u squared. And this is a differentiable function of x. So using chain rule, y prime here is equal to, we are first to find the derivative of y with respect to u. So what is the derivative of y here? Y equal to u squared. So by power rule, that is 2u, right? And then the derivative of u with respect to x. So what is the derivative of u here? We have u equal to 3x squared minus 2x plus 4. So the derivative of 3x squared is 6x, and the derivative of negative 2x is negative 2, while the derivative of 4 is 0, since it is a constant. So since we have the following values of the product, or we have dy, or the derivative of y with respect to u, and the derivative of u with respect to x, we just simply substitute that to the formula. So the derivative of y with respect to u is 2u times the derivative of u with respect to x, that is 6x minus 2. And since we are to find the derivative of y with respect to x, ibalik na to again ang value ni u. So that makes 2 times u. U na to is 3x squared minus 2x plus 4 times 6x minus 2. Then we simplify this. We'll get 36x cubed minus 36x squared plus 56x minus 16. So we have the derivative of the function f with respect to x. So another way of finding the derivative for this function using the composition of functions, the derivative of f with respect to x is the derivative of the outer function evaluated at the inner function. So we have an exponent 2 there. So we copy 2, and then we'll just copy the inner function without without getting the derivative of it. So we just copy that as is. So 3x squared minus 2x plus 4. Then 2 minus 1 because of the power rule. And then times the derivative of the inner function, that is 6x minus 2, right? Or that is 2 times 3x squared minus 2x plus 4. And then we are left with an exponent 1 here times 6x minus 2, right? So, same lang yapon ta og makuha using the other way. So, still, this is equal to 36x cubed. Kaya ito man na siyang i-distribute. Minus 36x squared plus 56x minus 16. So, same ra gyapon ta og makuha. Bisag aha or bisag unsa to ang gamiton. The composition of function formula for chain rule or kadtong mag-let any variable ta with the inner function. So, same lang. So, another example, what is the derivative of y equal to 3x squared plus 4x minus 5 quantity to the power of 5. So, the derivative of y here can have y prime equal to, we have the outer function and the inner function. So, copy 5. Then we just copy 3x squared plus 4x minus 5. And then 5 minus 1, 4 times the derivative, tama? The derivative of 3x squared plus 4x minus 5. So, we have 5 times 3x squared plus 4x minus 5 to the power of 4. Again ha, kani siya is gikan sa power rule nga 5 minus 1. Times the derivative, 3x squared, that is 6x, plus derivative of 4x, that is positive 4. Derivative of negative 5, 0, kay constant man na siya. So we have here. We can expand this, or we can simply let it be. This will be our final answer. Or we can distribute 5 to 6x plus 4 here. So, it's up to it's up to you. Or we can have this. 5 times 6x. We can distribute this since it has an exponent 1. Medyo taas na siya nga process if we will expand this with an exponent 4 pa. So, 5 times 6, that will give us 30x. 5 times 4, that is positive 20. And then we multiply by 3x squared plus 4x minus 5 to the power of 4. So either way or either answer will do. Another example, find the derivative of y with respect to x, where y is equal to the square root of 3x cubed plus 4x plus 1. And we all know that we can rewrite this as 3x cubed plus 4x plus 1 to the power of 1/2. So we have the outer function, it is clear, that we have an outer function and inner function here. And the inner function, the derivative is not equal to 1. So we'll make use of the idea of chain rule. So the derivative of y with respect to x here is equal to, we copy 1/2 times, we just copy the inner function 3x cubed plus 4x plus 1, and then 1/2 minus 1 times the derivative of 3x cubed, that is 9x squared. Derivative of 4x is positive 4, and derivative of 1 is 0. So we will emphasize the idea that we will just copy the first or the inner function if we are to get the derivative of the outer function. Isa-isa lang. Dili na to pwede duganon, no? So, outer function first, then copy the inner, and then derivative of the inner function na put. So, from this, we have 1/2 times 3x cubed plus 4x plus 1. 1/2 minus 1, that will give us negative 1/2 times 9x squared plus 4. So since we have a negative exponent here, we can rewrite that as, since 9x squared plus 4, positive nga exponent, so ipabili nato na siya sa taas. We have 9x squared plus 4, ipabili nato sa numerator, over, since ang 1/2, ang 2 dire is naa sa denominator, so naa pa na siya sa denominator. And then, since negative exponent ni, paubos nato na siya, we have 3x cubed plus 4x plus 1 to the power of positive 1/2. Positive na yung exponent. Since from numerator, i-down nato na siya to get a positive exponent. So, again, ibalik nato ni siya, pwede raman kani siya, pwede ra pod nga ibalik nato na siya to square root. So we have 9x squared plus 4 over 2 times the square root of 3x cubed plus 4x plus 1. This will be our final answer. Okay. Another example, find the derivative of y with respect to x, where y is equal to the quantity sine 3x squared. So, we have here the outer function. By power rule, we have 2 times sine 3x 2 minus 1 times the derivative of sine, consistent na lang nato, times the derivative of sine 3x with respect to x. So that will give us 2 times sine 3x, 2 minus 1, 1 na lang. Ngayon sa may derivative ni sine 3x. Derivative ni sine is cosine. Right? And then we'll just copy the pinaka-inner nga function, which is 3x. Tama? So, nahuman na tawa pa. Wala pa. Kay, napamantay kuhaan og derivative diri, which is 3x. So, times still the derivative of 3x with respect to x. So, we just copy this. 2 times sine 3x times cosine 3x, and then the derivative of 3x is 3. Or we have 2 times 3, that is 6, times sine 3x times cosine 3x. So we have our final answer. So sa chain rule, kung dili pa nimo makuhaan og derivative ang tanan function, kay magsugod man ka sa outer function, and then sa inner function, and then kung napag yung pinaka-inner pa jud, then wala pa tanahuman. Kuhaan pa jud na nimo siya og derivative. So, isa-isa lang, outer, inner, pinaka-inner, pinaka-inner pa jud. So, inana ang idea sa chain rule. The easiest way of saying it. So, consider the functions y equal to 3u squared plus 4u and u equal to x squared plus 5. Find the derivative of y with respect to x. So, mas dali, by chain rule, we can make use of this formula. Times derivative of u with respect to x. Where, so again, kay naman tayo y equal to 3u squared plus 4u. So, we'll find the derivative of y with respect to u. And that is 6u plus 4. So, balik ra gyapon ta basic sa derivative ang rules of differentiation. And then, since naaman tayo u diri, u equal to x squared plus 5, then pangitaon pud nato ang derivative of u with respect to x. So, kay x man diri. Okay, so derivative of x squared is 2x. Derivative of 5 is 0 since it is a constant. So, again, kaya na naman tayo mga values ani. So, we'll just substitute that para mas dali. So, ang derivative of y with respect to u is 6u plus 4 times the derivative of u with respect to x is 2x. So, since gipangita man nato is ang derivative of y with respect to x, ibalik nato ang value diri or i-substitute nato ang value ni u para puros na lang yun siya x, no? So, equal to 6. And say value ni u, x squared plus 5 plus 4. Tama? Times 2x. So, we'll distribute 6. We have 6x squared plus 30 plus 4 times 2x. And then, we have 6x squared plus 34 times 2x. And then, lastly, we'll distribute 2x. So, 2x times 6x squared, that will give us 12x cubed. And then 2x times 34, that will give us 68x. So, this will be our final answer. So, we're done with higher order derivatives of functions and chain rule. So, if you have questions, pwede ninyo na siya i-raise dito sa inyong group chat or sa inyong or comment mo dito sa inyong Google Classroom, and then we'll address that. So, try to answer all exercises kay wala man dyan ay paingnan dito raman po may manguha sa inyong problem set. So, kung giansira ninyo inyong practice exercises, then posible nga maka-answer jud mo sa inyong problem sets. And also, from the problem set, dito po may makuha sa inyong chapter exam. So, magbalik-balik ra gyud ang mga questions. So, mas maayo jud nga inyuhang yung ansiran inyuhang practice exercise. And then, sa inyuhang performance task, dito raman po minanguha sa inyuhang practice exercises. So, we'll have 2 more problem sets. The problem set number 7 and the problem set number 8. And then we'll have our chapter exam. That is, ang coverage is ang mga lessons sa derivatives. And we'll have our performance task. So, sa derivatives po na siya. So, actually, dili na makaya sa time. So, diri lang sa taman, inyuhang lesson sa basic calculus. And since inyuhan namang nagamay or kabalo na mo sa mga rules of differentiation, then that is basic for calculus. So, pwede na inyo na gamiton nga learning pag moabot na mo dito sa higher lessons na sa calculus. So, ang sunod nga topic actually aning chain rule is implicit differentiation, then applications na dayon using calculus. So, puhon, kung mo-take mo og calculus subject sa college, then dili ninyo ni dapat limtan nga lessons. Kay magbalik-balik raman Japon ni siya. And then eventually, makaabot mo na mo dito sa higher lessons. More lessons in calculus na. So, that's it. In behalf of the teachers sa basic calculus, we thank you for your patience, and we thank you for listening to us sa mga lessons, sa mga discussions. Puhon, magkita-kita rata. So, thank you for this semester. Thank you everyone and have a good day.